Okay, our directions are to solve. So before you even know that you need to use the quadratic formula, we need to distribute and clean this guy up. So 1/4 of 8, I'm going to get a 2. And x times x, I'm going to have an x squared. 1/4 of 12 is a 3. And let's bring this -9 to the left side, so we're set equal to 0. And you do want your squared term to be positive, so if it's not, I would divide by a negative, but we don't need to do that. So we're set equal to 0. I have a squared term. This doesn't factor. I'm kind of checking for that. So I know I need to use the quadratic formula. So I'm going to go into, this is A, -3 is B, and C is 9. So I take the opposite of B, plus or minus the square root of B squared, this will always be positive, minus 4 times A times C, all divided by 2 times A. So now that step's done and we need to just begin the cleanup process. Underneath the radical, I'm going to get a -63. And I'll go ahead and put this 4 under both pieces. And one thing that you want to notice is when your discriminant is negative, we're going to get an imaginary solution. And if I were to have graphed this in my calculator before I started the problem, it should not touch the x-axis. That's why I'm getting an imaginary solution. So I have to do a little bit of work on my 63. First of all, that's going to come out as an I. And then break 63 down. Any numbers that multiply to make 63 will work. I'll just start with 9 and 7. All right, so that means under my radical, I have a 9 and I have a 7. Square root of 9 is 3, so he's going to come out. And then the 7 is going to stay under. And then I could reduce here if they were reducible. They're not. And I could reduce these things, but they're not reducible either. So then this is my final answer.